All right, so I am solving by factoring. Okay, so first I'm going to check if there's a GCF, and then I'm going to factor. And then I'm going to say, okay, well, these factors all multiply to equal 0, and so one of them must equal 0, and so I'm going to set them equal to 0 and solve. Okay, so let's take a look. First, I'm going to ask myself, is there a GCF? In this case, I have just x squared out in front, so there is not going to be a GCF because there's nothing that multiplies to 1, 4, and 32, because there's nothing that multiplies to 1, right? So this is just going to be this. With just that x squared out in front, I can say, okay, I need two numbers that multiply to negative 32 and add to 4. The x squared comes from x times x. I'm multiplying to a negative, so I have one positive and one negative. I'm looking for two numbers that multiply to 32 and subtract to 4, right, because they'll end up subtracting with one positive, one negative. Those numbers are 8 and 4, and I'm going to go ahead and make the larger number negative since I want them to add to a negative. Okay, so now I have a number times a number equals 0. So either this number equals 0, okay, or this number equals 0. Look, these are the factors. This is one factor and another factor. So I'm making all the factors equal to 0, and then I am solving. So here I'm going to subtract 4 from both sides. I get x equals negative 4. Here I'm going to add 8 to both sides. I get x equals 8, and my solutions are negative 4 and 8. Over here, same deal. I notice there's x squared out in front, so no GCF. I'm looking for two numbers that multiply to 9 and add to 6. I notice that everything here is positive, so I'm going to go ahead and put positive, positive. Two numbers that multiply to 9 and add to 6 are 3 and 3. In this case, I notice that these two factors are the same, so either this equals 0 or this equals 0. I'm not going to write it twice, right? That's exactly the same. So I'm going to do this. I'm going to subtract 3 from both sides. I get negative 3. Again, this is the same, so I'm not going to write it again. I would literally be writing the same thing. In this case, I just have one solution, x equals negative 3. Okay, over here, I'm going to ask myself first, is there a GCF? And so this has not just an x squared out front, it has a 4. So is there a number that multiplies to 4 and 25? Let's see, numbers that multiply to 4, 4. Okay, 4 doesn't multiply to 25. 2 doesn't multiply to 25. So no GCF here. I notice that this is that pattern where there's a difference of squares. It's something squared minus something squared. Okay, we could also think of it like this. But remember that in this situation, these two are going to be the same, and they're going to multiply to this. There's going to be a plus here, a minus here, and these two are going to be the same, and they're going to multiply to this. Okay, so what's this? What times itself equals 4x squared? Well, 2 times 2 is 4, and 2x times 2x is 4x squared. And then for 25, what times itself equals 25? That would be 5 and 5. Okay, so now I have factor times factor equals 0. So either this equals 0 or this equals 0. Okay, in this case, I'm going to subtract 5 from both sides. Then I'm going to divide by 2. You can write this as just negative 5 over 2. That's fine. Or you can put it in your calculator. You would get negative 2.5. Either way, I don't care. Doesn't matter. Okay, and same on the quiz. You can plug it in either way. In this case, it's going to end up being exactly the same, only I'm adding 5. So instead of being negative, when I divide by 2, this is just going to be a positive divided by a positive, and it's going to be positive. So my two answers are negative 2.5 and positive 2.5. And again, if you want to put negative 5 over 2 and positive 5 over 2, that's fine. It's the same. Okay, next problem. I'm first asking myself, is there a GCF? And here, you know what? There is a number that multiplies to 10, 10, and 60, and that number is 10. And the other thing I notice is that they each have an x. Okay, so I'm going to pull out a 10x. 10x times what is 10x to the third? That would be x squared. 10x times what is negative 10x squared? Well, a positive times a negative. And then here, I already have a 10. I already have an x. I just need another x. There's two x's here. 10x times what is negative 60? That would be negative 6. Okay, so now I've taken out the GCF, and I need to just keep factoring this other part. I notice for the other part that I have just x squared here, so that's x and x. I need two numbers that multiply to negative 6 and add to negative 1. So multiply to a negative, I need one positive, one negative. And I'm looking for two numbers that multiply to 6 and subtract to 1. So those numbers are 3 and 2. And I want them to add to a negative. I'm going to make the larger one negative. Okay, now something really interesting has happened here. This is a factor times a factor times a factor equals 0. if this is equal to 0, or this is equal to 0, or this is equal to 0, the whole thing will be equal to 0. So I'm going to have three equations here, either 10x equals 0, x plus 2 equals 0, or x minus 3 equals 0, and I'm going to solve each of these. Here I'm dividing by 10, I get x equals 0. Here I'm subtracting 2, I get x equals negative 2, and here I'm adding 3, and I get x equals 3. So I have three solutions. In order from least to greatest, that would be negative 2, 0, and 3. Okay. Down here, I want to point out that these two problems look very similar, but there's an important difference, and the difference is this right here. Okay. Here, this problem is formatted more like this one. Look, it's something squared minus something squared. Look, something squared. In this case, it's x squared minus, this is 3 squared, right? So this is going to have this format. And a reminder that you can picture it like this and say, oh, this is just like, this problem. But look, I need two numbers that multiply to negative 9 and add to 0. Well, those two numbers are negative 3 and positive 3, right? So then either x minus 3 equals 0 or x plus 3 equals 0. Here I'm going to add 3 on both sides and get positive 3. Here I'm going to subtract 3 on both sides and get negative 3. And those are my two solutions. Okay, now this problem, even though it looks very similar, it's going to solve differently, because here, when I ask myself, is there a GCF? There is, right? This x squared means x times x, and this 9x means 9 times x. So this x is a GCF. So I'm going to factor out x, and then x times what is x squared? Oh, x. X times what is negative 9x? Okay, like this. Now, either this equals 0 or this equals 0. So either this equals 0 or this equals 0. Okay, here I'm solving this equation, and here the equation's already solved. I already have x by itself. So x either equals 0 or 9.